Yes, good afternoon, everybody. Welcome to this session of Sustainable Construction Methods. I'm Irfan Ahmed, Assistant Professor in the Civil Engineering Department, ISL Engineering College. Today we'll be seeing this topic, alternate building materials. Basically, what is the need for alternate building materials? We'll see that today. As you can see here, the demand for building materials has been continuously rising with the increasing need for housing both in rural and urban areas. As you can understand here, with the urbanization taking place, the need of each and every human being is to have a good shelter. So basically, they want to, if they live in a rural area, even there they want to have a good shelter, a good house. With if he lives in a hut, he wants to go for a good house with RCC buildings. So basically, what happens when these things are growing up day by day and the need is increasing day by day, then what is happening is the resources used to manufacture construction materials affect the environment by depleting natural resources, using energy and releasing pollutants to land and water. Now what is happening as the demand is increasing day by day, to manufacture these things, the construction materials also have to increase. Now to get these construction materials, what is happening is the natural resources which are available with us, they are reducing day by day. And because of that, to remove these natural resources and to get them into the desired form and shape, we need to go through some process where we get them as per our requirement. Thereby the usage of energy is also increasing, and because of that the output also sometimes is leading to pollution into land and water also. So the commercial exploitation of traditional building materials by various industries has aggravated the situation. As you can see, many big commercial setups also have been coming up. Because of that, what is happening? The depletion of the natural resources is very much high, whereas compared to when the need for only residential buildings and everything was there. So what is happening when the natural resources are getting finished very quicker? We need to come up with some solutions wherein we can try to save these natural resources available with us. We can reduce the energy, as well as we can try to reduce the pollution which is coming up from these industries. We can lower them. So it has therefore become necessary to think over this problem seriously. We need to think over this problem seriously, because we just can't keep using these natural resources and thereby leading to drying up of these natural resources, and to provide some sustainable solution to make the alternative materials available to solve the housing problem. So in this regard, we need to come up with some alternative materials where we can get the desired strength, as well as all our requirements can be achieved with some alternative material. So it is very high need. It is a matter of concern where we need to have some alternate material. Let us see today what are the different alternate materials which we can use in the housing construction sector, which can serve us all the needs which are served by the natural resources. Let us see the list of alternate building materials. You can see here we have hollow concrete block. We'll be seeing all the details of this hollow concrete block. What are the advantages and the disadvantages of all these materials? You can see fly ash bricks. Basically, what is a fly ash? It is a byproduct of thermal power plant. Rice husk ash. This is the rice husk is the wastage after the rice is got. The husk is removed from top of that rice. Ferrocement. Basically, we'll be seeing what is ferrocement. Tire veneer. This is the tire, which is the waste tire, which can be used as alternate building materials. Plastic wood. We'll be seeing this also. What is plastic wood? Synthetic fiber, recycled aggregate, fly ash, and bamboo. Let us see all this now. Hollow concrete block. You must have seen this hollow concrete block. Now let us see what is the use of this hollow concrete block and what are the advantages. See, concrete block is primarily used as a building material in the construction of the wall. Basically, as this is a brick, this is used for construction of the wall. It is sometimes called as concrete masonry unit also. It is called as CMU also. See, it is one of the several precast concrete products used in the construction. So basically, this is a precast concrete construct. These bricks are already precasted as per the size, and they are got onto the side. Normally what happens, they have very good strength, also, and they have a very specific shape also. You must have seen in the red bricks what happens is normally these red bricks, while from when they remove it from the kiln and then they are transported from the other place to the desired place, therein you can see the shape and size of these bricks are sometimes lost, and even the strength is also reduced. The term precast refer to the fact that the block are formed and hardened before they are brought to the job site. So basically, precast means that they are they are already casted beforehand before getting to the construction site. In use, concrete blocks are stacked one at a time and held together with fresh concrete mortar to form the desired length and height of the wall. So basically, what happens? These are already made of concrete, and then what happens is we put this mortar to fix one brick to the other brick, and thereby getting the desired result as we get for a red brick. Let us see the advantages. It has very low maintenance, and the color and brilliance of the masonry withstands outdoor elements. It has a very good color also. Normally you must have seen the red brick, it is red in color, and then on over that we go for plastering also. Here what happens is, as this is very smooth also, we don't require that much quantity of materials is also reduced in this brick. Load bearing, it is load bearing, strength can be specified as per the requirement. As I told you, just because it is precast, whatever strength we require, we can make it as per our requirement. It is fire resistance also. You can see it is very thick, it can resist fire also. It won't break away to the effect of fire also. It provides thermal and sound insulation also. So basically, when we construct a house, we want to see whether we have sound insulation as well as thermal insulation also. Even this property is also being maintained by this concrete block. The air in hollow of the brick does not allow outside heat or cold in the house. You can just see, just because they are hollow concrete blocks. So what happens because of this? As they are hollow, the outer air doesn't come inside and the inner air is not lost outside. So because of that, this what happens is, in summer these bricks are cooler, and in winter they are warmer. So this is the purpose it can be served because of that hollow concrete blocks. It is economical also. It is not too costly. The area what it acquires in regard to the red bricks, it is different, and it is economical also. It is environment friendly also. Fly ash uses one of the raw materials. We'll see what is the fly ash in the later slides. So these are the advantages of using concrete blocks. You can just imagine, it has good strength, it is economical, as well as a lot of area can be covered because of this block. And other thing is, when we go for plastering, when we go for finishing also, just because the surface is smooth, we don't require a lot of material is not required here. With some material can be saved to a very big extent here. So this is how we can save the construction cost also. Let us see fly ash bricks. See, what is fly ash bricks? Fly ash bricks are made of fly ash, lime, gypsum and sand. Now you might ask me, what is fly ash? See, fly ash is a byproduct of in thermal power stations. What happens? A huge amount of coal is burnt. Because of that, when the coal is burnt, this thermal power plants generate energy, generate electricity, but the byproduct, the waste what has got, that is fly ash. What we want to come up with, because the fly ash is in a very big it is in huge quantity. Now what we want to do is, we want to come up with solution with some thing where this fly ash can be used effectively. So these can be extensively used in all building construction activities, similar to that of common burnt clay bricks. So it has the same strength, it can be used of same common burnt clay bricks. Many experiments have been done, many tests have been done to this, and it has satisfied the proper requirements as we need. So this is the fly ash bricks. The fly ash bricks are comparatively lighter in weight and stronger than common clay bricks. You can just see here, fly ash bricks, they are lighter as well as stronger. So whatever the, basically we want to see what is the strength it can bear, and if it is lighter also, it is very good. So fly ash bricks is also very good alternate material where we can use instead of the red bricks that is made because of the natural resources, red soil. You can see the advantages here. It saves construction cost. As I have told you, due to the uniform shape and size of fly ash brick, it saves labor in laying bricks by about 15%. You can just see a 15% of your cost is being reduced by using this fly ash bricks. Just because it has smooth surface, as I had told you, the plastering, the material for the plastering can be reduced because of this smooth surface. This translates into reduction in labor cost in laying each brick, which is quite substantial. See, even the labor cost is also being reduced because of this fly ash bricks, because we don't require a lot of labor, as it is very lightweight also, and it covers a lot of area also. Even the labor is being reduced because of this. Less water seepage and dampness in walls, so the water seepage is also very less in this fly ash wall. Due to high strength and less water absorption of fly ash bricks, there are less water seepage and dampness in walls of building. You can see here, water also can't seep to these bricks, fly ash. It can't seep to this fly ash bricks. So even this is a very strong property which is achieved here. Less energy consumption. Huge energy is consumed in heating clay bricks and kilns. By using fly ash bricks, much energy is saved in brick manufacturing. See, even it doesn't require a lot of heating to get the desired strength. A little amount of energy, a little amount of heating can get us the desired brick as we want. Whereas in red clay bricks, what happens? A huge amount of energy is required to heat the clay bricks. After that, only we can get the desired strength of the brick. A reduction in air pollution also, even this is the advantage. Much fossil fuel is used in heating clay bricks and kilns. Burning such fuel generates air pollution and greenhouse gas. As the amount of energy is also being reduced to burn these bricks, naturally what will happen in turn, it will reduce the air pollution also. Air pollution and greenhouse gases also can be reduced because of lesser heating of these bricks, contributing to global warming. So it is reducing the greenhouse gases effects also. The global warming is also reduced because of this fly ash bricks. Let us see the next, rice husk ash or pozzolanas. You can see pozzolanas are materials containing reactive silica or alumina, which in their own right have little binding ability. So this product, it has very little binding ability. Now see, basically if we want to use this product, it should have binding ability also. Now what to do? Even because rice husk is also in a very huge, it is available in a very huge quantity. So we want to use this material where rather than just throwing it away and increasing the pollution, why don't we try out from some solution where this rice husk can be used as some replacement for some material. Yet when mixed with lime and water, it will set and harden like cement. You can just see here, when this rice husk is mixed with lime and water, it will set as harden like cement. It will set and also harden like cement. So basically what our requirement is, that is being achieved because of the rice husk. They are important ingredients in alternative cement compounds. Rice husks are a large byproduct. 1 ton is produced per 5 ton of rice paddies. See, from 5 ton of rice paddies, 1 ton of rice husk is got. You can just imagine what huge amount of rice husk is available. Just by treating with lime and water, we can get the desired results. And it is estimated that 120 million tons of husk could be available annually on a global basis. You can just imagine here, 120 million tons. A huge amount of rice husk is available. If this rice husk is treated with different, is treated with lime and water and other plasticizers also, we can get the desired result as the results we get when using the cement here. Let us see the advantages. Increase compressive and fragile strengths. Basically what we want to see is, when cement is mixed with other fine aggregates and coarse aggregates, then it becomes a concrete. In concrete, what we want to see, we see different tests. Some of the tests are compressive test, flexural test, and split tensile test also. So here what is happening, the compressive and flexural strengths are also increasing. So this is a very good sign. It is like it has very good property here. It reduces permeability also, so water can't seep through it. This is also has to be checked. So it has good permeability also. Increase resistance to chemical attack also. Sometimes what happen, where they in places where these materials are more exposed to water. In water there are different chemicals, and because of that there are chemical attacks also. So this can resist the chemical attack also. Where you have gone for construction, you have used this cement in like, you can just imagine here, if you have used the cement in a sewage line, you have poured a sewage line, and the sewage line, what happens with the polluted water. There are different chemicals are also mixed in it. Because of that chemical, the chemical reacts with this cement and these materials, thereby there are chances of these materials getting deteriorated. So what happens, this can resist this chemical attack also. It is very good. Increased durability, it has very good life also compared to different other materials. Reduces effects of alkali silica reactivity. As I have told you, in water, in different, there are, it is polluted with different things. Alkali silica reactivity also takes place. It can reduce those effects also. Reduce shrinkage due to particle packing, making concrete denser. What happens when we try to mix the concrete denser? We pour a little bit of water and try to make it denser, and that times also the particle shrinkage, it reduces shrinkage also. So if this shrinkage is very much more, then the lot of amount of concrete is needed. Here it is reducing shrinkage also. Enhanced workability of concrete. At the other side, we need to see whether it is workability is good or not. Basically, what is workability? The ease with which the concrete can be mixed, laid and spread. So this is the workability is also enhanced because of using this rice husk. Reduced amount of superplasticizer, reduced potential for efflorescence due to reduced calcium hydroxides. Basically, what happens, why do we use the superplasticizers is sometimes when the concrete doesn't get good workability, or sometimes the concrete doesn't reach the desired result. Under those conditions, we try to increase the workability of concrete and we try to gain the strength of the concrete. Thereby, in those situations, we'll have to use the superplasticizer. So because of good workability, the amount of superplasticizer is also being reduced here. So this has a very good advantage. You can see rice husk, it has very good potential. We can do research on this thing also. Let us see what is ferrocement. The term ferrocement is most commonly applied to a mixture of Portland cement and sand reinforced with layers. See, Portland cement and sand reinforced with layers. Basically, we have reinforcement also with layers of woven or expanded steel mesh and closely spaced small diameter steel rods rebar. So basically what, see, we have a mesh here, we have a steel mesh. Over this, the concrete is being laid in layers. Small steel mesh, but it has a very good strength. This is called as ferrocement. It can be used to form relatively thin compound curved sheet to make hulls for boats, shell roofs, water tanks, etc. When used in house construction in developing countries, it can provide better resistance to fire. See, it can provide better resistance because steel mesh is already inside this cement concrete, you can say as well, reinforced concrete, you can say. Used in like it has better resistance to fire, earthquake, and corrosion than traditional materials such as wood, adobe, and stone masonry. See, it has good resistance to fire and earthquake also, whereas the traditional materials what we use as wood and other stone masonry, they can't resist earthquake and sometimes the fire also. It has good resistance to earthquake as well as fire. Let us see the other advantage. You can see it. This is the ferrocement. You can just see this a steel mesh. You can see how that concrete, the cement mix with sand fine aggregate is poured into this steel mesh. You can see the layers. You have one steel mesh layer at the bottom, and then the mix is being laid, and then again the steel mesh is being uh, put in layer, put in the next level, and then the again the material is being poured. So this is the ferrocement. You can see advantages. It has low construction material cost. Ferrocement construction normally has the lowest material cost. See, it has the lowest material cost when compared to other materials. Different materials where we are trying to come up with some solutions where we don't use the natural resources, or we try to reduce the use of natural resources. So here it has the lowest material cost. Typically, the material cost in ferrocement is about 30 to 40, 30 to 50% of that for steel. See, you can see the material cost is also low. 30 to 50% that of steel cost is being reduced because of this ferrocement, because it is achieving the required strength here. Low ongoing maintenance. With proper design and construction, ferrocement vessels require only minimal ongoing maintenance. See, it requires very minimum maintenance, very less maintenance, whereas compared to other materials, they require a lot of maintenance also. You can see long operational life, durability is very good. Well designed and built ferrocement vessel has demonstrated that they have an extremely long economic life. 50 years or more is not uncommon. See, it has good economic life, durability also, 50 years or more also. So we don't need to worry when ferrocement is being used, it has good life also. Let us see tire veneer as flooring material. See, basically, what is tire veneer? Rubber tires play an essential role in modern life. We keep using the rubber tires. The automobile industry is growing day by day because of the demands of people moving from one place to the other place is increasing, and even people want to have good luxury also. So the demand for automobiles is increasing, and in that automobile industry, we have this rubber tires. Tires are essentially globally at all levels of development. So tire requirement is increasing day by day. Millions are discarded annually as they wear out relatively fast. What happens? Tires, you must have seen within 2 or 3 years, sometimes the tires they wear out and we need to replace this tires. But what about this tire which is not of our use? Where do we throw it? Why do we waste it? So we have come up with some solution where this tire can be used as a flooring material. This product makes use of recycling the material into usable material for various types of application. Now this material can be reused and it can be used in different applications. Let us see here what are the advantages. It is an environmentally responsive flooring material, resilient both indoors and outdoors. This flooring material can be used as in indoors as well as outdoors. Basically, this is a flooring material, this tire veneer. It can be used in areas such as sports and recreation, animal housing, and high traffic areas outdoors. You can just see where all it can be used in sports areas, recreation centers, wherein we tire animals also, and high traffic areas also. This can be used there. The variety of customer products can be made such as vibration dampeners and furniture surfaces internally. The other products also which can be made vibration dampeners. Basically, these dampeners are used in those places where there are high chances of earthquakes. There we go for dampeners also. So this can be used at that place also. It can be used for furniture surfaces also internally. Let us see what is plastic wood. Plastic wood. It was made primarily from high density polyethylene HDPE pipes. You must have seen HDPE pipes, or thick black pipes which are used for your water requirements. Or this pipes, this plastic is used for making drums also, where the drums contain different chemicals also. So this HDPE is recovered from the waste stream mainly in the form of used milk containers or recovered plastic. I see. Basically, these type of HDPE is used in milk containers. You must have seen thick containers of milk. So you can see that plastic which is being used, that is HDPE plastic. And from wood waste also that have been ground to a fine powder. So what we do is we take this plastic and we ground it to a fine pipe. First they are cut into small sizes, then they are ground into fine fiber. After that, what do we do? A 50-50 mixture of plastic and wood is common. So then what we do is we mix a little amount of wood, 50% and 50% of this plastic which has been shredded. This is being mixed together, 50-50%. Plastic wood is 100% recyclable material, recycled plastic. You must have seen that a lot of plastic is available. So this one HDPE plastic can be used here in construction industry also. See, it is 100% resistant to rot. The termites or other different things can't rot in it. So it is 100% resistant to it. Impervious to cracking and splitting. It doesn't crack and split also if it is installed correctly. Environmentally friendly and requires less maintenance. It's environment friendly also. If we don't use it, then this plastic can can pollute the area and increase the pollution. Waste plastic and wood is used for manufacturing. See, this is used for manufacturing also. It is a very good recycle waste. All woods may check, split, cup, crook, twist, and warp, and weather over time to a grayish color. See, all woods, all this can happen with the wood. Treated wood exhibits long-term durability. If the wood is treated, then it can exhibit long-term durability in a deck surface application, lasting as long or longer than natural durable untreated wood. See, if this wood is treated with this plastic, the durability also is increased here. So this plastic wood, as I told you, 50% of plastic and 50% of wood is mixed, and they can be used as a good flooring material. Let us see what is reinforced fiber concrete. Reinforced, basically reinforced is we are increasing its strength by putting fibers. Yeah, reinforced cement concrete means we are enforcing the strength in the cement concrete. The same way reinforced fiber concrete means we are reinforcing the strength by putting fiber into it. The fiber reinforced concrete is a concrete containing fibrous material which increases its structural integrity. You can see here the structural integrity is also increasing. When we use this fiber material, what happens? The amount of steel percentage can be reduced, as the strength what we need is can be achieved by this fiber concrete. It contains short discrete fibers that are normally distributed and randomly oriented. It are basically they are small wires. They are very small in size with a very small diameter. Basically, it is an mm that can be cut to the size. Fiber includes steel fibers, glass fiber, synthetic fiber, natural fibers. See fibers, you can see steel fibers, small wires like in a mesh. How do we get glass fibers? Small sizes of glass are cut. Synthetic fiber, natural fibers like you have fibers of bamboo fibers. Also, you have naturally available things that they are made into fibers by treating it. So reinforced fiber concrete gets can be used, and they give the proper strength as we require. Advantages: improve resistance to explosive falling in case of severe fire. If severe fire takes place, what happens is the cement comes off from the concrete. The cement comes off from your structural elements. So this provides very good resistance here. Very good resistance here to fiber, extreme fiber. Improves impact resistance. If there is sudden impact also, it gives good resistance in those conditions also. Sudden impact, sometimes it happens, accidental loading or some accident takes place. Because of that, there is huge amount of impact. Even that can be resisted here. Increase resistance to plastic shrinkage during curing. What happens when curing is done? There is a shrinkage which takes place. Even this is resisted by using of this material, fiber reinforced concrete here. Improve structural strength. As I told you, the structural strength also increases because of using this fiber, and reduces crack widths and control the crack widths tightly, thus improve durability. Now what happens when the cracks takes place? That those cracks are taken upon by these fibers. Thereby you won't see cracks in the structural elements where these steel fibers or other fibers are being used. Reduce steel reinforcement requirements, and I have told you, when we increase the steel fiber, the steel reinforcement, the main steel and the distribution steel, that can be reduced here. It improves ductility also. It provides good strength to the structural member. You can see a fly ash. What all we have cement application of using this fly ash, geotechnical applications. We can use it in our ground excavations and other. There also we can place these things. Filling applications where some a gap has been come up and we need to apply grout. At those places also fly ash can be used. Ceramic applications, in places where ceramic tiles and other things are used, in those gaps also this fly ash can be used. Agricultural application, different agricultural applications also, and engineering properties and other properties also, this fly ash can be used here. The advantages, as I told you, what are the advantages of these fly ash? It saves construction cost. The construction cost is reduced to a very big, huge extent. Reduction in air pollution. Yes, air pollution is reduced to a great extent, as the burning of kilns are not to that amount when compared to red bricks. So because of that also the air pollution is being reduced. Good compaction also can take place. High range of optimal moisture content. It has very good optimum moisture content also. High internal angle of friction. There is good internal angle of friction. Because of that the binding is very good. Free draining, less interruption due to rain. So it can drain out very easily. No large lumps to be broken, easy to spread. So in cement you must have seen, you get sometimes you get lumps also, but here you don't find those lumps here. Light in weight, can be used as weak subgrades. As I told you, it is light in weight. It is very beneficial here. Let us now see the other solutions where we can come up where we don't use, where we are trying to come up with some solutions or alternate materials which can be used, thereby lowering the natural resources also, the use of natural resources. You can see rural houses, you can just see basically what is a rural house. It is constructed in villages, and what happens, these rural houses are very cheap. Why? Because it is made up of bamboos, it is made up of wood, it is not made up of reinforced cement concrete. Most of the places it is just like a hut. You need some bamboos, and in place of cement and other aggregates, here we apply the mud. You can just see in rural house we can use fly ash brick because it is cheaply available and more strength. In rural house we can use the mud plaster because it can resist the temperature variation with tensile property. It can resist the temperature variation also. So mud can be used as a plaster in the rural houses. You can see advantages in this house. We can use the timber as beams and columns. As I had told you, what is being used here, so it can be used for beams and columns because it is easily available in rural area and having more strength. It has good strength also. Thick beams can be casted here. Wood beams, wooden beams. Plastering can be done with help of mud, so it is very easy. Mud can be used for plastering purpose also. The construction of house is very cheap, whereas in urban areas the construction is very high. You can't come up with this type of construction. It is your choice, but still normally nobody does this type of construction in urban areas. This are seen only in rural areas, but the construction cost is cheap. You can see a prefabricated house. Basically, what is prefabrication? It is the prefabrication is the materials whatever required are prefabricated in industry as per our size and shape, as per our requirement, and got to the site and fixed there. Thereby we have precasted columns, we have precasted beams, we have precasted walls also. You can see here the term prefabrication also applies to the manufacturing of things other than structures at a fixed site. Whatever we can require, we can just manufacture it and got to the site. You can see the advantages. Self-supporting ready-made components are used, so the need for formwork, shuttering and scaffolding is greatly reduced. See here, when it is prefabricated, what is happening? We don't need formwork, we don't need shuttering, everything is prefabricated and they are brought onto the site. There they are fixed using basically they are fixed using a nut and bolt system or welding, a dry weld or wet weld. These are two different terms that we can see it later on. Construction time is reduced and the buildings are completed sooner, allowing an earlier return for capital invested. So construction can be time is reduced because everything is prefabricated. You don't need to wait for anything like the where still if the excavation is being done, the size of the rooms, if is given to the industry, they can already ready up what the different sizes of walls also. So here we don't need to wait for anything here. On-site construction congestion is minimized. Quality can be easier in factory assembly line setting than a construction site setting. Prefabrication can be located where skilled labor is more readily available and cost of labor, power, materials, space and overheads are lower. So all these are the advantages in this type of construction here. Advantages, you can see a continued advantage in prefabricated. Time spent in bad weather or hazardous environments at the construction site is minimized. See, if there is bad weather, normally what happens? We stop our construction. We stop the construction. But here, as these are being manufactured in the industry, thereby we don't need to stop the construction work. Less waste may be generated, and in a factory setting, it may be easier to recycle it back into manufacturing process. For instance, it is less costly to recycle scrap metal generated in metal fabrication shop than on the construction site. You can just see it can be recycled also. It can be, this fabrication can be used furthermore also. Molds can be used several times. Once we make the molds, those type of molds can be used use also. You can just see a cost reduction areas. Let us see the cost reduction areas. What are the cost reduction areas? There are different methods from which cost can be reduced. We need to come up, we need to see this aspect also where the cost can be reduced. It is not that only alternate materials are being used and thereby the cost is getting increased. We need to see where we can reduce the cost of the construction also. They give same advantage of the strength while we reduce the cost. Some of them are, see, the strength is not being compromised, but only the cost is being reduced. Let us see some of them. What are they? Uh, Plinth, walling, doors and windows, and lintel. Basically what happens is plinth beam is being raised and walls are being raised, doors and windows are needed, and lintel is also needed. Let us see what we can do here. Plinth, it is suggested to adopt 1 feet height above ground level for the plinth and may be constructed with cement mortar of 1 is to 6. See, it can be constructed using only cement mortar of 1 is to 6 ratio also. The plinth slab of 4 to 6 inches, which is normally adopted, can be avoided, and in its place, brick on edge can be used for reducing cost. Normally, what happens in plinth beam is we put CC, cement concrete, in place of the plinth. There, what we can do is we can reduce this and we can use bricks also in place of this plinth beams or this material. By adopting this procedure, cost of plinth foundation can be reduced to about 35 to 50%. We can just see the amount of construction cost is being reduced to 35 to 50%, where we are not using that same material and not using that size of material 4 to 6 inches. Rather, we are just changing the material using brick. Providing a good plinth also, where we are not compromising with the strength part. Walling, in view of high energy consumption by burnt brick, it is suggested to use concrete block, which consumes about only one third of energy of burnt bricks in its production. And wall thickness can be reduced from 20 centimeters to 15 centimeters. See, if the concrete blocks are being used as we had seen in the previous slides, the amount of energy to burn them is reduced about one third also. Even the thickness can be reduced. With the red brick what we are using, the thickness is about 20 centimeters. Here we can reduce the thickness size also 15 centimeters. Concrete block masonry saves mortar consumption. Speedy construction of wall results in higher output of labor. See, it can be constructed in a very speed manner also. Plastering can be avoided, thereby an overall saving of 10 to 25% can be. Plastering also can be avoided here because it has a very good smooth finish, and thereby 10 to 25% of overall saving can be achieved here. Let us see for doors and windows what we need to do. It is suggested not to use wood for doors and windows, and it is placed, and in its place concrete or steel section frames can be used for achieving savings in cost up to 30 to 40%. Just because we need to come up with some alternate solutions where we can reduce these natural resources. Thereby we can see if we can use steel sections or concrete frames also. You must have seen normally the frames are being made in wood also. Here we can try to make those frames in concrete, and this doors and windows can be made in steel frames. Similarly for shutter commercially available, block boards, fiber or wooden practical boards, etc. shall be used for reducing the cost. Even wooden practical boards and other block boards can be used, thereby the cost can be reduced 25%. Lintels, basically these lintels, where do we provide the lintels? The traditional RCC lintels, which are costly, can be replaced by brick arches for small spans and save construction cost up to 30 to 40% over traditional method of construction. Basically, these lintels are placed where we construct a door or a window, where the whole load of the wall above the door and the window is resisted by this lintel. So here what we can do is directly, rather than constructing a door, why don't we give a arch? In arch, this arch you this whole arch can be distributed with different bricks, and the weight is also reduced, and also the cost is also reduced here by making this construction into an arch type. By adopting arches of different shapes, a good architectural pleasing experience can be given to the external wall surface of the brick. So even you get a very good appearance also, and a good finish also can be achieved here. So these are what we can see. You can see the conclusion. Let us see, by using this different other materials, what do we conclude? The demand for building materials has been continuously rising with the increasing need for housing both in rural and urban areas. As I have told you, the demand is increasing day by day. Everyone's need has been changed nowadays. Everyone want to have their good home or goods, their own house. Thereby the construction is increasing day by day, which is simultaneously giving a big jolt to natural resources available also. Selecting environmentally attractive materials with reduced environmental impacts is primarily achieved through the practice of resource conservation and selection of non-toxic materials. So basically, we want to come up with some materials which are non-toxic, where they don't increase the pollution, rather they decrease the pollution. So we have to take up some material which are non-toxic. The resources used to manufacture construction materials affect the environment by depleting natural resources. As we had seen just before, if you have fly ash or different materials, the construction cost is also increasing, and the natural resources such as energy is also increasing. Thereby the natural resources are getting reduced here. The most important feature governing the choice of material and form of construction for any component is its structural integrity. So here with this different materials we have seen, because using these materials it increases structural integrity also. So thereby using these different materials we can achieve a desired results and desired strength, and everything can be achieved here. So this we have followed this principles also, where there are 4 E's. It should be efficient also. The efficiency should be good. It should give us good results, good outputs. Economical, it shouldn't be too costly also. Energy conservative, the energy should, we should try to reduce the conservation of energy also. So even this should be seen. Eco-friendly also, it should be eco-friendly also. It should be easily available also. Thus, the discussed facts clearly state a wide and promising scope of alternate building materials in the construction industry. You can see here how different alternate building materials can be used in this construction industry, thereby reducing the natural resources available with us. If we don't use this alternate building material, then a day will come where we won't have natural resources available with us. So hope this session was informative to you. I request all the students to please go through this lecture, and if you have any questions, you can comment in the comment box. Thank you. Thanks a lot.